This first question, we could add the times on, add 24 minutes and keep going, and add 42 minutes and keep going, and look for where they match. They're quite big numbers, so I think it's not going to be particularly nice. So the way I would do this is to do the lowest common multiple of 24 and 42. Find out where in the times table you get the same multiple. And it's not necessarily 24 times 42 because they have some shared factors. So first things first, I know there's not loads of space, but I'm going to get my prime factorization. 6 and 4, 2 and 2, they're prime. 2 and 3. And I can write down that 24 is 2 cubed times 3. I can do similar for 42. I'm going to do it to try and fit it in down here. I'm going to get 7 times 6, 2 and 3. So 42 is 2 times 3 times 7. If I want to then get my lowest common multiple, I can draw a Venn diagram. They've got shared factors of 2 and 3. And then 42 ends up with 7 as well, whereas 24 ends up with another 2 and a 2. So the lowest common multiple is in fact 2 cubed times 3 times 7. I just multiply all of these together. Essentially, I'm doing 24 times 42, but I'm then dividing by the shared factors 2 and 3. And that will still be in both the times tables. Like you can see that 24 will go into this number and 42 will go into this number as well, but no number that's smaller would they both go into because you wouldn't have all the factors there. So it's going to be 2 cubed, which is 8, times 3 times 7, which gives us 168 minutes. Okay, so it's not actually as big as I thought it was going to be. Right, well, 1 hour is 60 minutes. 2 hours is 120 minutes. So this is going to be 2 hours and 48 minutes. I've then got to, okay, it's going to go over. So I've then got, it's going to be, if I add on 2 hours, I'm going to get to 17:19. And I've got to add on another 48. So if I add on 41, I'll get to 6 o'clock. And then I'll need another 7 minutes. So it's going to be 6:07. Awkward, really, with the times and everything. You could argue, to be fair, in this case, it might have been easier to just have done the times until you got to it. It's just it's quite tricky when you're going over the hour and everything. But 6:07, I think, is the answer. The second question is like a really cryptic way of asking for the highest common factor. We want the number that's going to go into both so that we can find the size of each group. We've still got a bit to do after that, but it's going to be a similar sort of thing, unless we can spot the highest common factor. But I'm going to go the safe route and work out the prime factorization again. So it's going to be 12 and 5, and then 4 and 3, 2 and 2. 105 is then going to be, I'm going to get 5 and 21, 3 and 7. So if I now do a Venn diagram for that, so my shared factors now are going to be 3 and 5, and actually that's all I care about. I don't care about the rest of it. The highest common factor is going to be 15. So I can have groups of 15, essentially. That will work. Then they'll be the same size, and I can get that from the 60 and from the 105 because they have to be the same year, so I can't split them up. And I'm trying to get it as few groups as possible. So we can't just have groups of 1 or just 5 because that would be, you're trying to make as few groups as possible. So I can do 60 divided by 15, which is going to be 4 groups. Oh, by the way, the size of each group is going to be 15. 4 groups of year 8. And then 105 over 15, which is going to be 7. That's going to be the number of year 9 groups. So if I add these out, the total number of groups is going to be 7 plus 4, 11.